Go, let's start. So,
What was the first one?
linear approximation.
Relax, bro. I want to go home.
What it is we're going to talk about a technique in order to approximate things like finding the square root of 101, finding the cube root of 33, things like that. Right? This formula should look a little bit familiar. It basically comes from first principle formula. So if you think about the first principle formula, okay, if you transpose that around, you end up with getting something that looks like that. So it's basically on that sort of principle, mucking around with first principle. How do we use it? I'll go through an example and then I'll show you what it actually ends up looking like. So, easiest thing like it. Say I want to find the square root of 101. Right? We're going to approximate the square root of 101 and relate it to this formula. As soon as you do that, you think, okay, do I know the square root of 101?
No.
No. What square root do you know that's closest to 101? 100. Right? So I could write this as square root of 100 plus 1. Okay? So I know how to find the square root of 100. I'm now going to estimate the square root of 101. Matching what this is. This is effectively f of x plus h. Right? That's the next guy that I'm trying to work out. I'm trying to work out the y value or the square root of 101. So I ask myself, what is the main job? What is the main task that I'm trying to do? Yeah, but what's the first job? Before I get to derivative, because that's the derivative, that's the main function. What is the main function I'm doing here? Square root. Yeah? I'm asked to square root something. So my main function is what I call the square root of x. So you look at the job and you say, what am they asking me to do? Cube root, square, whatever. That is what I write down as f of x, the main job. So that takes care of this section. I also need to find the derivative. So as soon as I've discovered the main job, I also find the derivative. And you derive square root of x. We all know the square root of x. The derivative of that, I'm hoping we know by now, is 1 over 2 root x. Scribble to the side. That's x to the half. If I was to derive that, it becomes half x to the negative half, which gets re-expressed like that. Yeah? Okay. So I've got fx, I've got f dash x. H represents the next gap. You know, when we do like in first principle, we reduce our h. You know, when you get closer and closer to get a tangent, this is almost the reverse of that. So h is the gap. It basically corresponds to the difference between the thing that you know and the thing that you want to know. So root 101, I know how to do square root of 100, I don't know how to do 101. The gap between the guy I know and the thing I want is just 1. So h is 1. It can be positive or it can be negative. So if I asked you to do square root 99, the closest guy I know is 100 minus 1. Does that make sense? So h is the gap, positive or negative, from the thing you know to what you want, that difference. So we know h, we know f dash of x, we know f of x. So we go into the rule and say basically the square root of 101 is the same as f of x, which would be the square root of 100, my main job, yeah? Plus h, 1. F dash of x is 1 over 2 square root of x, which in this case is square root of 100. So there's my main value, there's my derivative value, there's my h. If I do this, I get 10 plus 1 over 20, which is 10 plus, let's go decimalize, 1 over 20 is 0.05. So my approximate answer is 10.05. Go to the CAS and work out the square root of 101. Someone hit that. Square root of 101. And give it to me in 2 decimal places, please. Well, no, go 3 decimal places just to show something.
10.04987.
So if I, so 10.049.
Yeah.
Alright. I'm just emphasising something in a minute. Right, so we're pretty close. If we actually went to two decimal places, it's perfect. If we rounded, it'd be perfect. But the reason I don't want to round it up is to show you something else in what we're physically doing here. Right, what we're physically doing. Any questions about the actual operation? Tom, here.
What if it was 2 instead? So h equals 2. Would it become root 2?
Ah, good point. Thank you. No, h is the gap. H is the gap. You don't worry about the job. H is the gap. Very good question. Right, so if that said 100, if I asked you to do root 105, it'd be 100 plus 5. H would be 5, not root 5. Right? H is just the gap. You don't worry about the job. You just worry about the space. H is the space. Right. A thing they also ask you with this is, are you overestimating or underestimating the true value? Okay. Our job here is square rooting. That's what a root function looks like, square root of x. Cool. And I'm asking you an estimation around root of 100. So it's like, so wherever you are drawing a tangent and getting the next value. Okay, so there's a value that I know. That's where I hit the graph, and then that's what h is. H is my small gap. My next value, if I draw a tangent, is going to be above the graph. Can everyone see that? If imagine drawing a tangent there, your tangent for an increasing function here is above the graph, which means my answer will always overestimate the real thing. My answer was 10.05. The real answer is 10.049 something. So my answer is a little bit bigger than the real thing. Yeah? So that is an overestimation. And the reason I can tell it's an overestimation is when I look at my graph, if I draw a tangent, my tangent will end up being more and more above the real thing as I move on.